So we're going to take a look at factoring by grouping when we have four or more terms. So this is going to be really similar to using factoring by grouping when we're doing trinomials. So the only thing we need to really pay attention to here is step number one, which is that we need to make sure our like terms are grouped. Well, not like terms, sorry, terms with common factors are grouped. And then we're just going to treat it like we would treat sort of a middle step in factoring a trinomial. And the only thing to note is just like any other polynomial, if it can't be factored any further, we just call it prime. So let's take a look at this first one. So this one, it's already nicely set up with the terms with common factors already kind of grouped together. So these two factors here, these two terms here have a factor of x squared. These two terms here have a factor of 4, and then these first two terms also have a factor of 7. So we're just going to go ahead and factor those out. So if I factor out a 7x squared from these first two terms, I'm left there with a 3x plus 8. And then I want to factor a 4 out of these second two terms, so plus 4 times 3x plus 8. And then we're left with, that common binomial factor, 3x plus 8. So we have 3x plus 8. And then after we factor that out, we're left with 7x squared plus 4. All right, we always do want to just double check if we can continue factoring. Do we have a difference of two perfect squares? Do we have a factorable trinomial? Do we have another GCF that we can pull out? And in this case, the answer would be no, we're done. We can stop factoring. So we're going to look at a few more examples here. So just this first one, again, it's already grouped. So the first two terms, they have a common factor of 15x squared. So we'll go ahead and factor that out. We'll be left with 7x plus 3. And then this next one, you just want to watch your signs, right? So we know that our leftover binomial, we need to have both be positive values there. So I want to factor out a negative. So here I'm going to factor out the common factor of 12, but I'm going to factor out a negative 12 so that I get a positive 7x plus 3 so that we get that common binomial factor. So then finishing it off here, we have 7x plus 3, factored that out, and then 15x squared minus 12. And again, we just want to check for anything that we can factor further. So if I'm looking at this, I'm just going to take a moment to notice that 15 and 12 are both divisible by 3. So I actually want to factor that out. And when you're doing this, just keep in mind that multiplication is commutative. So I'm going to factor that out. So we would have 3 times the leftover. So I'm just writing it first. It would be 5x squared minus 4, then times 7x plus 3. All right, so you just want to make sure you're fully factored there before you move on. All right, so this one we need to regroup a little bit. So what I can see is that there are two terms that have a common factor of x, and then two terms that have a common factor of b. So I'm going to go ahead and just rewrite this, group those together for a moment. So now that we're grouped, we just want to factor out a common factor. So you could see that you have a GCF here and factor that out in the beginning, but honestly, I think it's easier to recognize them most of the time in the end and find the largest GCF so that you're not factoring a common factor multiple times. So what I'm going to do is out of this first one, I'm going to factor out a common factor of 48x and be left with 6y minus 1. Now, when I look at the second one, I know that my y term is going to need to be positive, but right now it's negative. So that's going to clue me into needing to factor out a negative value here. So I'm going to factor out a negative 40b, and that's going to leave me with a negative 1 plus 6y. And then I have the correct signs to have common binomials. So 6y minus 1 and negative 1 plus 6y, that's really the same thing, right? You want to remember addition is commutative. So then when we rewrite this, we have 48x minus 40b times 6y minus 1. So now I do still want to look and find any greatest common factors, and that first binomial there has a GCF of 8, so I'm going to factor that out. So we factor out an 8. We will be left with a 6x minus 5b times 6y minus 1. So you do just make sure you're looking for those GCFs. That's really the big thing there. Okay, so I want to take a look at just one last one. This is a rather large one. We want to group our common factors, and sometimes this takes a couple of tries, right, to see where your common factors are. But what I'm going to see is that there are three factors that have a common factor of A, and there are three terms, excuse me, I should say terms that have a common factor of B. So I'm just going to regroup those. So now that we're regrouped, we can factor out a common factor. So the first three only have that common factor of A, so we're just going to factor that out. And the last three only have that common factor of B. All right, now when we're looking at this, we run into an issue here because what's left over, these trinomials here, are not the same, which means we don't have another common factor to factor out, which is our indication that this is a prime polynomial that, even though it's long and kind of messy, it is actually as factors as it possibly can be. It's in its most simple form there. All right, so thus far, this is just a review of the factoring techniques that we have seen. So whether we're factoring sort of any number of terms, we can apply that GCF idea there, and we can pull out a GCF at any time in the factoring process. So for factoring by grouping, it's actually a little bit easier to find the GCF and pull it out at the end of the problem. For working with two terms, currently all we know how to do is a difference of two perfect squares. So that's, a squared minus b squared is a plus b minus b. We're working with three terms or trinomials. We know how to factor a general trinomial, so leading coefficient 1 or not 1. And we also know the special case how to factor perfect square trinomials. And then four or more, we can factor by grouping and of course apply that GCF term, that always applies for all of these. All right, so let's just back here. We're looking at a perfect square minus another perfect square. Look at factoring completely, factoring some of these by pulling out a greatest common factor and then factoring by grouping, or maybe having a trinomial or a difference of two perfect squares or something else going on in there. So if we're looking at this first one, all we're really looking at is needing to factor out a GCF. So again, you can do it at the beginning or at the end, and I prefer to do it at the end for these when we're factoring by grouping. So I'm going to pull out a 20x squared here from the first two. And then, let's see, I know I want my x term to be positive, so I'm going to have to factor out a -5 from these last two terms so that we have matching binomial factors. Then we have a 20x squared minus 5 and a 2x minus 7. Now here's where we're getting into multiple steps, kind of like we did before, where we have that GCF that we need to factor out. So they have a greatest common factor of 5. So I'm going to factor that out. We're going to be left with 4x squared minus 1 times 2x minus 7. Now we can go even further, right? Because if I'm looking at this, this is a difference of two perfect squares, right? So if we refer, right, so I want to factor this even more. So I'm going to have 5 times, factoring this, 2x plus 1, 2x minus 1, and then we still have that 2x minus 7. So we're applying all of the different strategies in one factoring problem where we just need to keep looking at the individual factors and determining if we can factor them further. So let's get one more done here. So this time maybe we'll factor out the GCF first. So if I'm looking at these, they're all divisible by 3p. but I'm also going to regroup them. So let's regroup first. Let's see, we have common factor of p, and then we have common factor of f squared. So I'm going to regroup them and then we'll pull out a GCF at the beginning just to see what that looks like. All right, so we're all grouped. Let's go ahead and factor out that 3p to start. So 3p. All right, so actually these two have a common factor of h that we're going to be working with, but that's all right. So we're working with 40ph minus 48qh minus 30qf squared plus 25pf squared once we factor out that GCF here. So we're going to go ahead and continue by factoring out some common factors here. So let's see, so we have our overall GCF of 3p. Then out of the first two terms, we can factor out an 8h. We'll be left with 5p minus 6q. And then here, we just want to be careful with the sign of what we're factoring. So most of the time when we see a negative as the first term, we want to factor out a negative. That's not the case here because I want my q term to remain negative. So I'm actually just going to factor out, let's see. Oh, it looks like I had a touch of a typo here. This should be a 30. There we go. That makes more sense. So we're actually just going to factor out a positive 5f squared. And we'll be left with a negative 6q plus 5p. So the reason I did that is because in the first binomial here, I have a negative 6q. So I need that to be mimicked over here so that we have that common binomial factor. So we can clean this up. We have 3p, and then we have our common binomial factor, which you can factor out 5p minus 6q, and then we have 3p plus 5f squared. And we just want to look at it and make sure we can't factor it any further, and we cannot, so we can end there.